Hello friends, today we are going to learn about linear equations in one variable. Well, before I proceed ahead, let me explain you what is the difference between an equation and an expression. What do you mean by an equation and what do you mean by an expression? What is the difference? Okay, an equation will be in the form of, I'll give you an example, 2x plus 3 is equal to 5. So this is an equation. So wherever you have this equal to sign, okay, this sign equal to sign is there, so then that becomes a equation. And how about an expression? An expression is thus just x plus 4, okay, y plus 6. So these are called as expressions, but things like these are called as equations. X plus 2 is equal to 5. This is an equation. Okay, so now we know what is an equation and what is an expression. So whenever we have this equality sign, equal to sign, it's called an equation. And when we don't have that equal to sign, it's just a variable plus a number. Okay, it could be one variable, it could be two variables, it could be more than two numbers, anything, it could be anything. But things like these are called as expressions. Clear? Now, having come to know what an equation is and what an expression is, let us try to understand the word linear. What do we mean by the word linear? Linear means any of that equation whose power of the variable is only 1. It should not be more than 1. Okay. Example, as I told you, three x plus 4 is equal to 0. The power of x here is 1. So this is a linear equation. So any variable which has got the power, the exponent, the power as only 1. So that is called as a linear equation. Such equation whose variable has got power as only 1 is called as a linear equation. Okay, I can give you many more examples. 2y plus 6 is equal to 9. This is a linear equation. Why? Because the power over here is only 1. The power over here is only 1. Okay. Equations like 3x squared plus 5 is equal to 7 is not a linear equation. This is not a linear equation. Why? Because the power of the variable is more than 1, greater than 1, it's 2. Okay? Right. Now, having understood the difference between an equation and an expression, now we know what an equation is. We also know what a linear equation is. Okay? So we know what a we know the meaning of the word linear. We know what is an equation. We know what a linear equation is. We know what a variable is. Okay, variable, any alphabet or whose value we are trying to find out. Okay, now having come to know all these things, let us try to take some examples and find the value of x. Suppose if I take x minus 3 is equal to 7. Now this is a linear equation. Okay. So this is a variable, this is a constant number, this is also a constant number. So what we do is, we need to find out, normally the purpose of solving such equations is finding the value of the unknown quantity, that is the variable. Okay. Now how do we find out? So what we do is, all the variables to one side, and all those numbers which does not contain any variable will go to the other side. Example, x is equal to 7 minus 3. So we transpose 3, it becomes plus. So minus becomes plus when it goes to the other side. Okay, so this becomes x is equal to 7 plus 3. That would be equal to 10. So the value of x, therefore x will be equal to 10. That is the answer. You can always cross check. Okay, so whether your answer is right or wrong. Suppose if I put the value of x is equal to 10 here, let me check whether I get 7 or not. 10, if I put here, 10 minus 3 is what? 7. I got it. So my LHS is what? X minus 3. My RHS is what? 7. Okay. So LHS means left hand side of the equation. RHS means right hand side of the equation. Now x is 10. So 10 minus 7, I get here is 3. 10 minus 3. That is 7. On the right hand side also I got 7. Both are equal. So LHS is equal to RHS. So it got satisfied. Clear? Right. Now going further, I'll give you some more problems. Let us solve some more problems and see. Once you are clear with the basics, then it becomes easier for you. How do you solve this? 3 by 7 plus x is equal to 17 by 7. Now here x is the variable. Okay, we need to find the value of x. This is a constant number. This is a constant number. As I told you, we'll keep all the variables on one side and transpose the constants to the other side. So in this case it becomes x is equal to 17 by 7. When this is transposed to the other side, the sign changes. It becomes minus 3 by 7. So what do you get ultimately? You get 14 by 7. 17 minus 3 is what? 14 by 7. And 7. So the answer would be 2. Okay? That is how you find the value of x. So such equations, solving such equations is called as solving of linear equations in one variable. So we are able to find the value of x now. Okay? You have seen it. So x is only one variable. We have only one variable in this equation. And we are able to find whatever maybe it's a fraction, the numbers are in fractions, or maybe in whole numbers, whatever it is, or real numbers, whatever it is. Still we are able to find the value of x. Right? Now we'll do some more problems. Supposing I give you 2x by 3 is equal to 18. 2x by 3 is equal to 18. How do you solve this? Now this is the variable x here, okay, along with the coefficient 2 by 3. Okay. Now 2x by 3, 2 is the coefficient, denominator is by 3. What we'll do is 18 by 1. So we'll cross multiply. Okay, so on cross multiplication, what do we get? 2x is equal to 18 into 3. Okay, so that will give you 54. Now x will be equal to 54 by 2. That is what? 27. Right? So the value of x here is equal to 27. You know how? 54 divided by 2, 2 to the 4, carry 1, 2 7 the 14. Right? Or you can do it directly over here. By 2. 2 9s are 18 and 9 3s are 27. You get the same value. Either ways you get the same value. Value remains unchanged. Okay? So this is how we solve and find the value of x in equations which are called as linear equations in one variable. Now we'll take one more example. 1.6 is equal to y by 1.5. How do we do this? Again, on cross multiplication. We have you have 1 over here, okay? Now y is equal to 1.6 into 1.5, correct? Now if you multiply these two, what do you get? Fifteen 6 are 90. Carry 9. 15 plus 9 is what? 24. Two decimal places. So the answer would be 2.4. Correct? So the value of y over here is 2.4. So this was a linear equation. Okay? And y in y. So far we were having a variable x. So here the variable is y. It could be anything. Okay? So we need to find out the value of y. So we found the value of y is equal to 2.4. Correct? Next. We'll take one more simple equation. 7x minus 9 is equal to 19. Okay. Now 7x is equal to 19 plus 9. 28. And 7x is equal to 28. Dividing both sides by 7. If I divide both sides by 7, what do I get? X is equal to 28 by 7. Because 7 by 7 get cancelled, okay? This will be 4. Right? So the value of x here is equal to 4. So these are simple equations. So this is how you can solve and find the value of the given variable. It could be x, it could be y. So now you know how to solve the problems based on linear equations in one variable. If you want, if you're interested, I can give you some more problems. And try this. Let's try this. X by 3 plus 1. Is equal to 7 by 1.5. No, 7 by 15. Okay. How do you solve this? This is nothing but x by 3 is equal to transpose. You get 7 by 15 minus 1. Okay. That will give you what? 15 is the LCM. So here you get 7 minus what? 15. Right? So 7 minus 15 is what? 8. So x by 3 is equal to minus 8 by 15. Why minus 8? Because 15 is, the greater number has got a minus sign. 7 minus 15 is minus 8. Right? Now, x will be equal to how much? X is equal to multiplying both sides by 3. If I multiply this by 3, what do I get? X by 3 into 3 is equal to minus 8 by 15 into 3. Okay, so this 3 and 3 get cancelled. I get x is equal to 3 5 are 15 minus 8 by 5. And this is the answer. Okay. So this is how we find the value of the unknown quantity. Now these linear equations have got a lot of importance when it comes to finding the value of the unknown quantity, unknown variable in practical use. Practically, when we are into the field and trying to find the unknown variable, okay, like you were supposing you want to find the ages, then in such a case, yes, this chapter becomes paramount importance. Now, we'll take I think applications of these. Supposing I give you a sum of two numbers is 74. Okay, one of the numbers is 10 more than the other. Okay, now what are the numbers? What are the numbers? Now how do you solve this? He says sum of two numbers is 74. One of the numbers is 10. One number is given to you. Okay, so that means let the other number be. Let the other number be. We'll take some variable x or y or whatever it is. Okay, so x, we don't know the value of x, we are trying to find out. So he says one of the numbers is 10. One of the numbers is 10. Oh, 10 more than the other. Okay, so let the one number be x. So the second number would be 10 more than the 10 more than this, x plus 10. Correct? Now, sum of these two numbers is 74, he says. So that means what? First number plus the second number is equal to 74. Right? Now, if I solve it, now we have an equation. We have already formed an equation, framed an equation. Once the equation is framed, then you can easily solve as we have seen earlier and then find the value of x. So x plus x is what? 2x plus 10, because here we add the coefficients. 2x plus 10 is equal to 74. Now from here you have done previously, you can solve easily and find the value of x. Okay, so 2x will be equal to 74 minus 10, that will be 64. So x will be equal to what? 32. Right? So this, he says sum of two numbers is 74. One of the numbers is 10 more than the other. Suppose this number is 32. The second number is 10 more than this. 10 more than this means what? 42. Now sum of these numbers would be 74. 42 plus 32, if I add, it becomes 72. So it gets satisfied. Right? So the answer is correct. So x is equal to 32. So what are the numbers? So one number is 32 and the other number is second number is 10 more than this, is equal to 32 plus 10, 42. Okay, therefore sum of these two is 74. 2 plus 2 4, 4 plus 3 7. Right? So this is how we solve problems wherein applications are given to us using application problems. Correct? I think we'll stop here and do some more application problems in the next class. Okay. Okay then, thank you. Take care.